Hello friends, welcome to the session. A continuation of chapter 7, that is DC to DC converter. In this topic, in this concept, types of choppers based on quadrant operation. In the last session, I discussed about type A, type B, type C and type D choppers. So these are I discussed. Now another type of chopper based on the quadrant operation is type A chopper. After completing type A chopper, in this session I will start with the steady state analysis of type A chopper also. Okay, that you can see. Yes, type E chopper. It is a 4-quadrant chopper. It's a 4-quadrant chopper. Okay. What is the circuit you are using for type E chopper? Draw the circuit parallelly. Yes. Yes. This is CH1, CH2, CH1, CH2, CH3, CH4, D1, D2, D3, D4. Type E chopper consists of how many switches and how many diodes? 4 switches plus 4 diodes. This is assumed current direction. This is assumed voltage polarity. Okay. Now see, if you take only this one, what is this chopper? You tell me. Take only this part. What is this chopper? Type C. That's why a type E chopper is realized by combination of two type C choppers. Or if you take like this, these 2 switches, 2 diodes. 2 switches, 2 diodes, type D. 2 switches, 2 diodes, another type D. That's why it is combination of 2 type C choppers and 2 type D choppers. It is combination of cells. two type C choppers, two type C choppers, or two type D choppers. Two type D choppers. Like that we can realize. We know that one type C chopper is operated in first and second quadrant. The opposite type C chopper is operated in third and fourth quadrant. Then we can operate this chopper in fourth quadrant. One type D chopper is operated in first and fourth quadrant. Opposite type D chopper is operated in second and third quadrant. Then chopper is operated in fourth quadrant. Like that we can realize as a four quadrant chopper. Therefore, it is four quadrant chopper. It is four quadrant chopper. Four quadrant chopper. Now the question is how to control the load or motor in four quadrant, or how this chopper is operating in four quadrant, that I want to explain. That is the four quadrant operation. But one point to remember here, I given numbering. Actually, according to standard notation, what are the numberings you follow? This 1, 3, 4, 2. Okay, in so many circuit in rectifiers and inverters also I given how to follow the notation. 1, 3, 4, 2. That is standard notation. But I given 1, 2, 3, 4. This I taken 2. Okay. That means here I am not following the standard notation. Here I am giving the numberings according to quadrant operation. This switch is operating first quadrant. That's why one I given numbering. This switch is operating second quadrant. This switch is operating third quadrant. This switch is operating fourth quadrant. That's why here we are giving the numberings according to quadrant operation, not according to standard notation. Even numberings also change. But point to remember, this is always controlled in first quadrant. This is controlled in second quadrant. This switch is controlled in the sense on off. This switch is controlled in the fourth quadrant. Then only this circuit is operating in the fourth quadrant. Understood? That's why the numbering is not according to standard notation, according to quadrant operation. Now we'll see how to explain the four quadrant operation of this chopper. How this chopper is operated in the four quadrant. All of you note down this four quadrant operation of type E chopper. V0 minus V0, I0 minus I. S is forward motoring, forward braking, reverse motoring, reverse braking. Forward motoring, forward braking, reverse motoring, reverse braking. In this, PH1 operated. In first quadrant, PH1 operated. Here, PH2 operated. Because I given numbering according to quadrant operation. PH2 operated. In this, PH3 operated. In this, PH4 operated. Okay. Now, PH1 operate means if PH1 on and off in such a way that V0 positive, I0 positive. CH2 is on and off, V0 positive, I0 negative. Then only it is a second quadrant. CH3 on and off, V naught negative, I naught negative. CH4 on and off. I naught positive, V naught negative. Like that we can operate the circuit. Tell me. If CH1 is on, along with CH1, other device must to conduct to maintain the closed path. But during the conduction of that, V naught must be positive, I naught must be positive. Like that, which device will conduct? Tell me. Here, I am turn on the CH1 to make the CH1 and to make the V naught positive and I naught positive. Which device must conduct? Yes. If CH1 is on, CH4 must be conduct. No other device will satisfy. If you want that, you can check. Positive means during the operation of chopper circuit, if the current is same that of assumed direction, I naught is positive. If the voltage is 0 or voltage is if the applied voltage is positive, negative or voltage is 0, then we can take V naught is positive. Okay. If CH1 is on, along with CH4 must be conduct. CH1 and CH4 conduct. Then if CH1 and CH4 conduct, this CH1 and CH4 is conducting. This is the current direction. The same assumed direction, I naught is positive. If CH1 and CH4 is conducting, this positive wire is connected here, this negative wire is connected here, this is positive, this is negative, positive, negative, same polarity, then V naught is positive, I naught is positive. Then in this case, V naught positive, I naught positive. But one operation is nothing but one on and one off. Now we can turn off CH1. CH1 is off. Already which device is conducting? CH4. Then along with that, then which device must be on? If CH1 is off, then automatically next device will on to satisfy that quadrant operation. If CH1 is off, already CH4 is conducting, then along with D2 must be on. No other device will on to satisfy this. CH4, D2 will conduct. No sir, CH2 will conduct means meaningless. These two devices will opposite, will not conduct. Which I am representing like this, it will conduct only downward direction. I am representing diode like this, it will conduct like this. Sir, why you take D2, you take D4? That is meaningless. CH4, D4 will conduct means that is meaningless. Okay, that's why the current must be through load. That's why if CH4 is on, if the CH4 is on condition, if CH1 is off, which device will conduct? D2 will on. CH4, D2 will conduct. Now tell me. If CH4 D2 is conducting, load is short circuited now. Load is short circuited means what is V naught? 0. If CH4 D2 is conducting, current is flowing like this now, same that of assumed direction. I naught positive. I naught positive. Now resultant you tell me. Resultant. V naught positive, V naught 0. V naught positive, V naught 0. Resultant V naught is positive. I naught positive, I naught positive. Resultant I naught is positive. Then V naught positive, I naught positive. Which quadrant? First quadrant, forward mode. And that means this chopper is operated in the first quadrant. CH1 and CH4 will conduct. CH4 D2 will conduct. If CH1 is on, CH1 CH4 is conducting. Important. If CH1 is off, CH2 CH4 D2 will conduct to satisfy first quadrant. Like this, these devices will operate in the first quadrant. Because question may be expected. Then which of the following device will conduct in the first quadrant? Which of the following device will conduct in the second quadrant? Like that also we can expect the question. To answer this analysis is important. Directly also, without analyzing, just by seeing the circuit, how to write also I will give later. But you remember this is the concept. Okay. Then what about CH2 operated? CH2 operated means CH2 is on. If CH2 on. If CH2 is on means along with another device must be will conduct. If CH2 is on, okay, I will turn on CH2. Then another device must be conduct to satisfy this voltage positive, current negative. If CH2 is on, if CH3 you take, for example, if CH3 you take, this positive is connected here, this negative is connected here, this minus plus, this plus minus, but you get negative voltage now. That's why CH3 is not on. If CH2 is conducting, along with another device, I will take the D4. Then whenever I will take the D4, no doubt at all we can get V0 0. Positive voltage means we get 0 voltage also, no problem. That means if CH2 is conducting, along with which device must conduct? D4. CH2 D4 will conduct. CH2 D4 will conduct. Tell me, if CH2 D4 is conducting, what is V0? 0. If CH2 D4 is conducting, current direction is opposite to this one, I0 is negative. But one operation is nothing but one on and one off. CH2 is off. Then already which device is conducting? D4 is conducting. Along with which device will conduct? If CH2 is off, already D4 is conducting. Along with which device will conduct? D1 must be on. Yes, sir. D2 will not on. This is meaningless. Opposite, it will not conduct. Okay. If D4 is, CH2 is off means D1 must be on. If D4, D1 is conducting, then the current direction is like this. Then opposite, negative current. But positive wire is connected here. This negative wire is connected here. Same polarity, you can get V0 is positive. But you have that, sir. Positive wire is here. D1 is reverse bias. How do D1 is conducting means because of energy stored in the inductor. Again, don't research this one. Positive is connected here. Diode is reverse bias. How D1 will conduct? Like that, don't think. Okay. Because of inductance. Without conducting, we cannot realize this circuit. Okay. D1 must be conducted. CH3 operated. Yeah, sorry. CH2 is off. D4, D1 will conduct. If D4, D1 will conduct, what is V0? Positive. What is I0? Negative. Tell. V0 positive, V0 0. Resultant V0. V0 positive, V0 0. Resultant V0 positive. I0 negative, I0 negative. I0 negative, I0 negative. Resultant I0 negative. V0 positive, I0 negative. Which quadrant? Second quadrant. That's why in second quadrant, which devices will conduct? If CH2 is on, CH2 D4 will conduct. If CH2 CH4 is, if CH2 is off, D4 D1 will conduct. Okay. V0 positive, I0 negative. Which quadrant? Second. Like this we can control in second quadrant. Then what about CH3 operated? If CH3 is operated means CH3 is on. If CH3 is on, along with another device must conduct. Tell me. If CH3 is on, then which device will conduct to make the current is negative, voltage is negative? Yes. CH3, CH2 will conduct. CH3, CH2 will conduct. CH3, CH2 will conduct. If CH3, CH2 is conductor, what about I0? Negative. What about V0? Negative. Except this, if CH3, CH2 will conduct, current is opposite to assumed current direction. Then if CH3, CH2 is conducting, this positive wire will connect here. This negative wire will connect here. This positive, this negative. But this is positive, this is negative. Opposite to this one. That's why you can get V0 positive, V0 negative, I0 negative. But our operation is nothing but one on and one off. CH3 is off. Already which device will conduct? CH2. Then along with which device will on? If CH3 is off, already CH2 is conducting. Already CH2 is conducting. Then which device must conduct? D4 must be conduct. Then only I0 is negative. CH2 D4 will conduct. If CH2 D4 will conduct, V0 0. What about I0 negative? Now tell me. I0 negative, I0 negative. Resultant I0 is negative. I0 negative, I0 negative. Resultant I0 is negative. V0 negative, V0 0. Resultant V0 is negative. I0 negative, V0 negative. Which quadrant? Third quadrant. Like this, these devices will operate in which quadrant? Third quadrant. Which device will conduct in third quadrant? This I am giving according to this notation only. If notation is changed here, according to that you change the notation here. Understood? Okay. Now, if CH4 is operated, if CH4 is operated means, if CH4 is on, one operation, CH4 is on. Along with another device must will conduct. If CH4 is on, which device will conduct? You tell me. Yes. If CH4 is on, you want to get voltage is positive, current is negative, you want to get. Sorry. Current is positive, voltage negative, you can get. Yeah. CH4 is on means D2 must be conduct. CH4, no other device will satisfy. CH4, D2 will conduct. If CH4D2 will conduct, what is V0? 0. What is I0? Positive. If CH4D2 will conduct, this is the direction, same that of assumed direction. But CH4 is off. If CH4 is off, then already which device is conducting? D2. Till now, up to now, which device is not conducted? Till now, yeah, D3. Then D2, D3 will conduct. If D2, D3 will conduct, what is V0? V0 is negative. What is I0? Positive. You check the condition. If D2, D3 will conduct, his current direction is same assumed direction. This is the direction. What about this positive wire is connected here. This negative wire is connected here. This is negative, this is positive. Negative, positive, positive, negative. Opposite. V0 is negative. Then resultant you tell me. V0 positive, V0 negative. Resultant V0 is negative. V0 is negative. I0 positive, I0 positive. Resultant I0 positive. Now you tell. V0 negative, I0 positive. Which quadrant? Fourth quadrant. Like this, these devices will conduct in which quadrant? Fourth quadrant. Like this, we can control the chopper in fourth quadrant. Understood? Hold on, quick. This is the four quadrant operation. Without analyzing the circuit, these devices in which quadrant, which device will conduct directly also you can write. For that, we can follow the two rules that I will explain. Quick note down. I am explaining for first and fourth quadrant, which device will conduct. To find, see, this is not a concept, just for remembering purpose for objective pointer that I am telling. For first and fourth quadrant, okay. For first and fourth quadrant, first cross, first diagonal, this is diagonal, first diagonal, and you take opposite to analyze this one. Apply this rule. First diagonal, next opposite. For example, in first quadrant, start from this, you remember as it is. This is first quadrant chopper, second quadrant, third quadrant, fourth quadrant, like that you remember. First quadrant chopper, first diagonal, CH1, CH4, no device will satisfy. Sir, this is also diagonal you take, but this device like this device like this, it will not conduct now. Yes, CH1 and CH4. Next opposite, CH4, D2. Sir, this is also opposite. That is meaningless. This device like this device like this. These two devices will conduct in opposite direction. No, that's why CH4, D2 only possible. CH4, D2. Then even for first and third quadrant. This is not for first and third quadrant. For first and third quadrant, one rule we follow. For third quadrant, which is third quadrant? This one. CH3 opposite CH2. CH3 CH2. First diagonal. Then opposite. CH2 opposite is D4. CH2 D4. That means in first quadrant, CH1 CH4 CH4 D2. CH1 CH4 CH4 D2. Satisfied. In third quadrant, CH3 CH2. First diagonal opposite. CH2 D4. CH3 CH2. Then CH2 D4. Over. Then what about the second and fourth quadrant? You follow another rule. In second and fourth quadrant, first opposite you take. Next to diagonal. Like this you follow. For example, I am applying this rule. Then in second quadrant is this. First opposite, CH2 D4. Opposite is CH2 D4. Next to diagonal, D4 diagonal is D1. Then you can apply for fourth quadrant. First opposite, CH4 opposite is D2. CH4 D2. Then CH4 D2. D2 diagonal is D2 D3. This is satisfied now. CH4 D2. D2 D3. This is first quadrant divisor. This is third quadrant divisor. This is second quadrant divisor. This is fourth quadrant divisors will conduct. This I am giving according to this notation only. If notation is changed here also you change the notation. But Concept is like, okay. This about in detail analysis of what exactly type E chopper, how this type E chopper is controlled in 4 quadrants. How this type E chopper is controlled in 4 quadrants. We are controlling 4 quadrant means in first quadrant it must satisfy V naught positive, I naught positive. In second quadrant it must satisfy V naught positive, I naught negative. In third quadrant it must satisfy I naught negative, V naught negative. Used for reverse motoring. Then in fourth quadrant it must satisfy I naught positive, V naught negative. It is the forward motoring, forward braking, reverse motoring, reverse braking. For motoring you are applying braking, that is nothing forward braking. For reverse motoring action you are applying braking, that is nothing but a reverse braking. Understood? Okay, this about in detail about what exactly type E chopper or 4 quadrant chopper. Clear? Discuss steady state analysis of type A chopper. For every chopper we can do the steady state analysis, but mainly according to any computative point of mainly concentrate on type A chopper steady state analysis. Yes, concentrate, very important concept. Steady state analysis of type A chopper. Yes. Yes. Let us consider type A chopper with RLE load. By considering with RLE load. With R, L, E. This freewheeling. Yes. The supply voltage is take VDC or VS you take. No problem. VS or VDC. Any notation you can expect. Chopper or switch. This is type A chopper with RLE load. Okay. Here I am doing the steady state analysis with respect to RLE load. Then by using this RLE load, I want to calculate what is the maximum current, what is the minimum current. Once you know the maximum and minimum current, what is the ripple current, and what is the RMS value of freewheeling diode current, what is the average value of switch current, all these with respect to RLE load, I am analyzing this circuit. Okay, for type A chopper. Listen. First, you see the chopper is on, then freewheeling diode is off. Assume that it is a continuous mode. We are operating this circuit is under the assumption of constant current. We are supplying the constant current to the load. It is a continuous mode of up. With that assumption only I am explaining. Okay. Yeah. Chopper is on. One operation is nothing but one on and one off. Chopper is on. Then what the freewheeling diode? Freewheeling diode is under off state. Chopper is on. For 0 less than t less than t on. This is chopper is on. For 0 less than or equal to t less than or equal to t on. Then what the equivalent circuit? Yes. Chopper is on. This R L C. This is chopper or switch. Apply the KVL for this loop. Okay. Then what is the KVL you tell me? I into R plus L into di by dt is equal to Vs. Vs or VDC. Any notation you follow. This is Vs. I into R plus L into di by dt is equal to plus E is equal to Vs. Then from this, what you write? I into R plus L into di by dt is equal to Vs minus E. Let it is a continuous mode. If the chopper is on, the inductor is storing the energy. Let the initial current in the inductor is, if the chopper is on, inductor storing the energy. This I am explaining for continuous mode. This is V0 and this is current waveform. Chopper is on during T on. This is T on. V0 equal to Vs. This V0 equal to VDC or Vs. VDC or Vs. And the chopper is off. This one. That you will see. This is off time. This total time period is T. This is T on is dt. Let this is continuous mode. Continuous mode, already there is some initial current in the inductor. Then current is changing from minima to maxima and maxima to minima, again minima to maxima. Let this is a continuous. This is I minima. This is I max. This is I minima. Okay. This is average current. This peak to peak is ripple. Peak to peak ripple. Okay, minima to maxima. Then I want to draw the freewheeling diode current. Even this waveform is already given, even the step down chopper. TypeA chopper is also called step down. I will draw. This is chopper is on. I into R plus L into di by dt is equal to Vs minus E. Okay. Now tell. Then apply Laplace transform. The initial current in the inductor is, what is the initial current in the inductor? The initial current in the inductor IL of 0 equal to I min. This is initial current in the inductor, in the chopper is on. Then apply Laplace transform on both sides. If you apply Laplace transform on both sides, then what we can get? R into I of s plus Ls into I of S or with initial condition how to apply Laplace from L into S into I of S minus I of 0 IL of 0 IL of 0 is equal to, it is a constant na, Vs minus E by S. Okay. Now take I of 0 is common, R plus Ls, R plus Ls. This is equal to Vs minus E by S plus, then what we can calculate, plus L into IL of 0. What is IL of 0? I minima. Then I of 0, then this is I of S. Then what is I of S equal to Vs minus E by S into R plus Ls plus L into I minima by R plus Ls. Okay. I'm solving for I of t expression. If switch is, if chopper is on. Shall you write like this? Then I of S equal to Vs minus E by, take L is common, L into S plus R by L into S plus, what we get, take L is common, I minima by S plus R by L, S plus R by L. Then what you can get, I of S equal to Vs minus L is common na, Vs minus E by L, Vs minus E by L into 1 by S into S plus R by L plus 1 by S plus R by L into I minimum. Then you convert this into partial fractions, A by S plus B by S plus R by L, and you find what is the A value and B value and apply inverse Laplace transform. By simplifying and applying inverse Laplace transform. Applying inverse Laplace transform. What you can get, inverse Laplace transform. If you apply inverse Laplace transform, then what you can get, then I of t equal to Vs minus E by R into 1 minus E power minus R by L into t plus I minima into E power minus R by L into t. This is the expression for I of t if the chopper is on. You calculate A value and B value. We can get A equal to L by R. L cancel. B equal to minus L by R, you can get. L cancel. Then 1 by R is common. Vs minus E by R. 1 minus E power minus R by L into t plus I minima into E power minus R by L into t. Let this is equation 1. All this I am doing in order to calculate what is the minimum current and maximum current, and we want to make some observations. Once you know the minimum and maximum current, what the ripple currents also you can calculate. Okay. Then one operation is nothing but one on and one off. Chopper is off. Which is on? Freewheeling diode is on. Tell me. If the freewheeling diode is on, chopper is off, freewheeling diode is on. If the freewheeling diode is on, what is the equivalent circuit? This is the equivalent circuit. R, L, E. R, L, E. Chopper is off. This is Vs. Okay. Then freewheeling diode will conduct like this. Then apply KVL for this loop. I into R plus L into di by dt plus E equal to 0. Now apply Laplace transform. Let freewheeling diode is on for T on. less than or equal to T dash less than or equal to T. Freewheeling diode is on during this one. Here freewheeling diode is conducting. Here freewheeling diode is on. If the freewheeling diode is conducting, then we get the wave shape like this. This is the freewheeling diode waveform. What is the shape of the freewheeling diode waveform? It is a trapezoidal waveform. Trapezoidal. Okay. Now again apply Laplace transform and inverse Laplace transform. We can get one equation. That is one method. But no need of that. Directly by applying these conditions here, whatever the conditions are there, if freewheeling diode is on, you substitute that condition here, directly you can get the expression for what is I of t. Directly I am writing I of t dash equal to. That means I of t dash equal to these conditions. If the freewheeling diode is conducting, what is the source voltage? Source voltage 0. This we can substitute. Minus E by R into 1 minus E power minus R by L into, let this is t dash. That time is t dash. But if the freewheeling diode is conducting, what is the initial current? The freewheeling diode is started from this point now. The initial current is not minimum. The initial current is I max. If the switch is on state, switch is on from this point, initial current is I minima. Freewheeling diode is on from this state. That's why initial current is I maxima. That's why what we can get I maxima into E power minus R by L into t dash. Okay, this is no need to again make a Laplace transform, inverse Laplace transform, all these. You substitute the conditions in this equation, then we can get. If the freewheeling diode is conducting, minimum current, initial current is that this is initial current. If the switch is conducting, this is the initial current. Initial current only substitute here na I minima. Here what is the initial current? I max. This is the expression for I of t and I of t dash. This is the current if the switch is conducting. This is actual expression for current if the switch is conducting. This is the actual expression for current if the freewheeling diode is conducting. Okay. Now you see, listen please. We want to solve these equations to solve the minimum and maximum current. You tell me. If t equal to t on, whenever current is reaches to t on, whenever t is reaches to t on, the current is reaches to maxima. That means at t equal to t on, I of t becomes I max. You substitute I max here. Replace t by t on. Then you can get one expression I maxima in terms of I minima. Similarly, at t equal to t off, whenever t equal to t off, then current is reaches to which value? I minimum value. Then replace I of t dash by I minima. Then you can get expression I minima in terms of I maxima. We get I maxima in terms of I minima. Here we can get I minima in terms of I maxima. Then by solving these two expressions, then we can get the what is I minima and what is I maxima. Now I want to write what the expression for I minima and I maxima. Once you know what is the minimum value of current and maximum value of current, then you want to calculate peak ripple current. What is the condition for maximum ripple current? All these I want to explain. Okay. In the next session, we will continue with how to solve these two equations. Okay. Continuation of this one in the next session. Okay. Thank you.